In the previous lesson on creating helper methods back in day one, I was emphatic about where the method definition that we were writing should be positioned in the code. The method needed to be contained within the correct code block in order to work correctly. Methods have to live in special code blocks called classes. And in this video I want to talk about how to use classes that have already been defined in the .NET Framework class library, as well as how to create and use your own custom classes. As you're going to come to learn virtually everything in C#, in the .NET Framework, in Silverlight, and all of its Windows Phone 7 functionality is a class or it's part of a class. That's really the purpose of this lesson. Not so much that you can create your own classes necessarily, although that's going to be required to some extent as we move through these videos. The intent is really to use the classes that are built by Microsoft and available through the .NET Framework-based class library. The truth of the matter is that I can't possibly cover everything there is to cover about classes because it's a vast topic. If you really want to learn about the power of classes, then you're going to need to learn more about object-oriented programming. But that's a topic for another day. I want to present just enough so that you're comfortable with the basics of how to use existing Silverlight and Windows Phone 7 classes, as well as how to create super simple classes that we're going to wind up using on our big application that we're going to create on day 4. Okay? So as you can see in our Visual Studio IDE, I've set up a project called Simple Classes, and it just has a button. I didn't get fancy. I left the name button 1. We're not really going to focus on the displaying anything to the user just yet. But I do want to work within a code block here, and so that's why I created the button. Okay. So before I start writing code, here's the most simplified explanation of classes that I can possibly offer. Picture a car in your mind. Not a specific car, but rather the essence of what makes a car a car. It has 4 wheels, typically, a steering wheel, it has brakes, it can accelerate, it can brake, it can park, and so on. Those are just things we've come to expect all cars to be able to do. Cars can hold between 1 and maybe as many as 8 passengers, and some can hold even more. Cars have a manufacturer, they have a color, they have a year, a model, and other things that describe a specific car. Okay, so when you begin to think about the general characteristics and the actions that a car can take, that defines a car. You're thinking in terms of a class of things in the world, and that class happens to be a car class. You're abstracting away the particular details of any given car to talk about just those interesting features of a car that might be important as you begin to write software. So how would you write or represent a car within your software applications if you were asked to do that? Well, you would first create a generalized description of a car in C# code. So what I want to do is position the caret of our cursor. Actually, let's delete some stuff here. Alright, what I want to do is position the caret so that it's right before this ending curly brace and before that second from the end curly brace. Now if I were to roll up this code, you could see the public partial class main page is all kind of rolled up together. That might be an easy way to find the right position. You don't want to write the code inside of an existing class. That's possible, you just don't want to do it. Okay, so here's what I'm going to write. Great. Okay, we just created a car class. Now, admittedly, it doesn't really do a whole lot yet. We're going to add on some functionality in just a few moments. First, the keyword class tells the compiler what type of code block that we're attempting to create. We're going to give this class code block a name, and we're going to call it a car. And we'll see how this is used a little bit later in a following step. A class can have many different parts, but we're going to keep our car class simple for now. In this lesson, we're going to be creating some properties of a car, some attributes of the car. For example, we'll create a make and a model, a year and a color, and that'll help us differentiate one instance of a car class from another instance of a car class. We'll also create a couple of methods as well, like an accelerate method and a decelerate method. Backing up to a property defines an attribute of an of a particular instance of the class. So I'm driving an instance of a car class. You're probably driving an instance of a car class, and many people throughout the world are driving instances of a car class. They each have different makes and models, years. At the very least, they have a different PIN number associated with them, right? So there are some things that differentiate one car from another. So just keep those thoughts in mind as we begin to develop some software. We're gonna particularly be interested in just 4 properties: the make, the model, the year, and the color for now. We've used properties many times already whenever we were working with the button, with the text box, and the text block controls. We set properties like the name of the control, the text property, the content property, the text wrap property, and so on. This is the same idea when we're creating our own classes. We can set their attributes in code, or we can retrieve their attributes in code, like we'll do in just a few moments. A method is a named body of code and typically represents something the class can do. We created helper methods in one of the previous lessons about creating simple helper methods, and to actually do something meaningful, like perform some super secret formula calculation. So in our car class, we're going to create a method for the car to accelerate and a method for the car to decelerate. And there are several different ways, first of all, to define each of these. Let's start off with properties. A couple of different ways. I'm going to show you the easiest way to do it. So I'm going to position my mouse cursor inside the car class, and I'm going to type in the words prop, the word prop, P-R-O-P, and then I'm going to use the tab on my keyboard twice. Alright, and so when you do this, a macro in Visual Studio called a code snippet is executed, and it creates a line of code that you see here in the video. Notice that the word int is highlighted kind of in a gray color, in a blue-green color maybe. This indicates that you can currently replace that part of the code snippet with your own code. So I'm going to start typing string, and you can see that it allows me to change the value of int into a string. And now I'm going to hit the tab button one more time and one more time, and we move that selection from that first part to the next part called my property. And here's where I'm going to give it a name, and I'm going to call this the make. Alright, and so I could keep using the tab key on my keyboard to move back and forth between the two areas of my code snippet. When I'm finished editing this line of code, I'm going to hit the enter key on my keyboard twice. The first time I hit the enter key on the keyboard, it goes to the end of the line. The second time I hit the enter key, it goes on to the next line. And so I can continue to create additional properties in that way, just using the keyboard shortcuts. This little technique that I just demonstrated, it's the code snippet plus auto-implemented property technique. This again is a shortcut. There is a longer form of the property that we can define. I took a shortened form. In other videos and tutorials, you can see that there are a couple of different ways to define properties. This is the most simple way to do it, and it's a good way just to get your feet wet and get started, but there's a lot more to it than that. Just keep that in mind. Okay, so what I want to do is use the same technique to create the other properties of my car. So I'm going to create a model, a year, and a color property. So I'm going to type fairly quickly here, prop, tab, tab, string, tab, tab, model, enter, enter. Okay, prop, tab, tab. We want a year, so I might leave it as integer this time because I may want to subtract years. So I'm going to tab over to the name, call it year, and then hit return, return. And then I'm going to do another prop, tab, tab. I'm going to change int to string, tab, tab, and then rename the property to color, enter, enter. Okay, so I've created 4 properties, and we'll use these in just a moment. It's important to understand, though, what we just accomplished. We are creating a blueprint for a car in code. Just as in real life, however, a blueprint is just a plan. It's not an actual instance of the car. To do that, we're going to need to manufacture a new instance of the car according to blueprint, and we're going to do that in just a moment. Before we do that now, we've created our properties. Let's create a couple of methods. And so to do that, Let me take a look here. Okay. We're going to kind of follow the same steps that we did previously when we were creating methods that returned string values, those helper methods we were working on in a previous video. This time what we want to do, however, is create a public void accelerate. And then in the body of this, I'm just going to type write code here to make it accelerate. I'm going to take the cheap and easy way out. I'm not actually going to implement this right now. And we'll do the same here. Write code here to make it decelerate. Okay, but you know, previously we did private string name of method. Now we're doing public void name of method. The public means that it's accessible outside of its code block. So as long as you have a reference to a car, an instance of a car, you'll be able to access these properties. They're public. We could create private helper methods inside, but then no other code block could access those methods that we create. Same is true with these properties. We make them public so that they're accessible outside of the class code block. Okay. Then the other thing that we've defined here is void. What does that mean? It means that don't expect any return value from this method. Previously we had it defined as a string, so we would expect to use the return keyword to return a string, whether that's a variable or a hard-coded string, a literal string. So in this case, we're going to return nothing. So everything it needs to do, it'll accomplish right inside that that code block. Okay, so you know, these were really just for placeholders. I wanted to demonstrate the basic syntax. You've already seen how to create methods. This is how you create methods inside the context of a class. All right, so now we've created our car class. Suppose that I wanted to create a program that keeps track of my company's used car inventory. It would be great if each time my purchasing agent was out at an auction, he'd be able to enter the basic information about each car that he purchases in his Windows Phone 7, and then that information is transmitted back to our database that contains the entire inventory. This way it'll reduce the amount of data entry that somebody has to do once the car actually makes it back to our main offices. Okay, so as the developer, I'm going to need to collect some basic information about the car in the user interface for our phone application using text boxes and other input controls. Then I want to create a new instance of the car class, and I'm going to take the properties that were filled out in the text boxes. I'm going to take the value of those and input those into the properties of my car class. And then finally I would transmit an instance of this car class back to a centralized server where it would be stored in a database. Alright, we'll cover all that in due time. Not right now. Maybe not even in this series of videos, but you'll learn how to do that at some point. Okay, but to begin that process in my program, what I want to do is create a new instance of this car class that I've defined here for each new car that is going to be added to my inventory. So to accomplish that, I'm going to go back up here whenever somebody clicks the button and says, please submit this new car into our database. What I'll do is create a new instance of the car class. So car, my new car, equals new car. And we've used this same sort of syntax before. We used it when we were creating a date time object just a little bit earlier in this in today's videos, and you may have seen it once or twice even prior to that. Let's start off by saying this, that an instance of a class is also known as an object. Said that earlier. Again, an object is not a class, and a class is not an object, although sometimes you're going to hear people, even me, confuse those terms accidentally while we're speaking. Okay? The class is the blueprint. An object is instantiated from the blueprint, and then we can manipulate the object in memory. So think of this new operator as a factory that creates a new car. Okay, and so once it rolls off the assembly line, now we can get in our new car and we can drive it, we can use it. Okay, hopefully that analogy helps out a little bit. So what I'm going to do next in the lines that follow is I'm going to start setting these properties in code And I'm just going to go ahead and hard code them. I could pull them from text properties of input boxes, input text boxes, and so on. But we'll just hard code them for now. So I'm going to go my new car dot make, and notice that IntelliSense helps me out here. It recognizes the class, and so I can just now use the equal sign on my keyboard to autocomplete the text. But this is a great way for me to inspect a class that I'm not already familiar with. So I'll set the make to Oldsmobile. My new car dot model equals Cutlass Supreme. My new car dot year equals 1986, and my new car dot color equals silver. Okay. All right, so let's dissect this code. First, I use the name of the instance of the car class, my new car, to access each of the properties of the car class that I'm going to set. Notice that the period is the way that you get to the properties of an object. It's called the member access operator. Okay, that's something we covered previously when we talked about operators and operands. So once I have a new instance of my car class and I've set its properties, then I can do some useful things with this instance of car that I've named my new car. For one thing, it's a nice collection of all the properties that define the car in one little container. Secondly, when I create the class, I've really created a custom data type, just like any other data type that we've been using in our applications, such as string or integer. And since I created a new data type, I can pass that type around as parameters or return values from methods. So in this case, what I can do is create a helper method that will allow me to accept an instance of the car class called car, and I'll just look up the value of this car in, like, you know, some the blue book that gives us the current value of a used car. Okay, so let's write a method that kind of simulates that. I'm going to create a little helper method inside of my my main page class, and I'm going to call it determine market value. So I'm going to go private double, because I'm working with values that might be monetary. Okay, so I'll need some points after the decimal point. I can't use integer in that case, so I use a different data type we haven't discussed yet called double. But that's its main feature. It can hold very large numbers, including numbers after the decimal place. Okay, so I've reverted to a different data type than what we've been using up to this point. Hopefully that doesn't throw you for too big of a loop. Determine market value, and then it's going to be of type car, and I could probably call it something like my car, but just to show you that I can do this, I'm going to call it car. So I'm passing in a variable, or an input parameter rather, called car. What's its data type? Its data type is car. Now notice that as I hover my mouse cursor over it, it recognizes this to be a class. So it sees the fact that I've already defined the car class down here in line 46, and now I'm able to use that as a data type, in this case as a data type for an input parameter inside of a private helper method that I created in a whole other class. All right, so here I'm not going to do anything all that exciting. Car value equals 0.0, and then here I can write code to go online and look up the car's value and retrieve its value into the car value variable. All right, I'm not going to take time to do all that just yet. That's a little bit more advanced. We'll get to that eventually. Whoops. All right. So I'm just going to return back the value of the car. We'll just always set it to 0. But I think that the most important thing here is that you can now use this class that we've defined as an input parameter. And notice now, if I were to access car and hit the member access operator, I can see I can get the color, the make, the model. I can pass these values into over the web and some web service that sits out on another website, and then retrieve a value back, parse it out, and then return it here in the determine market value method. So that's how I would continue to access it. It gives me an instance of the class, a reference to it that's been passed in to my helper method. Okay. So then what I would do here in my button one click event is call that helper method like so. Okay, so here I'm just passing in an instance of car. This can accept an instance of car, do something meaningful with it, and return back a dollar amount. All right. Admittedly, in our car inventory application, it's less important to have methods like I've defined here. Methods like accelerate and decelerate. So as programmers, we may not use those, but perhaps in our second job, we're asked to create an application that predicts traffic patterns on our highways by running through scenarios of acceleration and deceleration for various cars. In that case, having those methods on each car object in our computer's memory becomes vital, while some of the properties of each car, like its year, its color, its make, its model, those don't become so important anymore. Depending on the type of application we're writing, we can pick and choose those attributes of a car that are most applicable to the kind of software that we are tasked with building. Okay? It's just picking out the right abstractions for our purposes. All right, so let me stop right there, and we'll pick this back up in the very next lesson to continue on with this thought, because there's more to say about this. But I want to recap what we've talked about so far. First of all, a class is a basic building block of C#. Almost everything in the .NET framework is a class. So you're going to need to understand the basic parts of a class and how to create new instances of classes in your application. Secondly, classes are blueprints. You have to create a new instance of a blueprint, a process called instantiation. Remember, we use the new keyword to create a new instance. That's kind of like a factory. It builds a new instance of the blueprint for us so that we can use it. What results is a instance of a class that is also called a object. Right. Third, classes can define properties and methods. Properties are attributes of the class. Methods are actions or behaviors of the class. And so we've seen examples of these many times already when we were working with the Silverlight button, text box, and text block controls. And then fourth, we learned that when we define classes, we're actually creating a custom data type, just like the data types that we've been using up to this point, such as string and integer. We're creating a more complex custom data type. In this case, we created a car data type. And then we can use that data type all over the place, such as what we demonstrated here as an input parameter to a method, just like we talked about. Okay, so that kind of wraps up the ABCs of classes. We're going to pick it right up here in the next lesson. We'll see you then. Thank you.